This video discusses how to differentiate the exponential functions with bases other than the natural base e. The prerequisites for this section are: you should know how to differentiate the natural logarithm function, which means the functions of base e. Remember, we saw that the differentiation of ln x, natural logarithm x, or in other words, logarithm base e x. If you differentiate this with respect to x, the answer is equal to 1 over x. That's the first prerequisite for this discussion. The second prerequisite is you should also remember how to do the implicit differentiation involving natural logarithm, which means, let's say you have to differentiate natural logarithm y with respect to x. We know this is equal to 1 over y times dy by dx, simply the chain rule. The third prerequisite is you should also remember the properties of logarithm. We already looked at the first three properties of logarithm. You should remember those three properties of logarithm for this section as well. So let me go ahead and quickly write them down before starting the discussion today. The first property is logarithm to a base a m times n. If you have it like that, we know the answer is logarithm base a m plus logarithm base a n. The second property is logarithm base a m divided by n. In this case, this is equal to logarithm base a m minus logarithm base a n. The third property is logarithm base a m raised to the r is equal to r times logarithm base a m. Of course, even for this section, even though we are going to look at the exponential functions with the bases other than base e, we are still going to use the natural logarithm. So all of these results can also be applied for natural logarithm. That means the base is e. So let's see how to differentiate the exponential functions whose base is other than the natural base e. So here's an example. Let's say I would like to differentiate 2 raised to the x. How do you do that? Some other examples for the exponential functions whose base is not the natural base is, let's say I would like to differentiate 6 times 5 raised to the x times 2x plus 5 raised to the 3x squared plus 1. That's a bit complicated function, but we will see how to differentiate these kinds of functions. Differentiation of these kinds of functions is also not very difficult. Often the equation should be given to you as y equals something. Maybe if it's given just as a function f of x equals any of these kinds of functions, you can still label that given left hand side as y. And the first step of that function y equals f of x is take natural logarithm from both sides. When I say both sides, please remember that I'm talking about a function of the form y equals f of x. On the left hand side, you only have a y. So when you take natural logarithm, on the left hand side you can write this as natural logarithm y. On the right hand side it will be natural logarithm f of x. For this process, of course, f of x should be positive. The second step is you're going to simplify the right hand side using the properties of logarithm. And that's not all. You still have to differentiate. In the third step, you differentiate both sides. Of course, it will be with respect to x if the given function is a function of variable x. All right, let's look at some examples. Here's your first example. Differentiate y equals 2 raised to the x. So what's the first step? Step number 1 is to take natural logarithm from both sides. On the left hand side, I will have natural logarithm y. On the right hand side, I will have natural logarithm 2 raised to the x. The second step is to simplify, of course, the right hand side using the properties of logarithm. So which property is applicable to simplify this right hand side, natural logarithm 2 raised to the x? I can use the third property. What was the third property again? If you have logarithm to any base a, m raised to the r should be equal to r times logarithm to that same base a, m. So the base a is equal to base e in natural logarithm, And you can see that this x can be written right here. So when I do that, this equation becomes natural logarithm y equals x times natural logarithm 2. Any further simplifications are not possible. Now we can differentiate both sides with respect to x. If you differentiate natural logarithm y with respect to x, what do you get? It's implicit differentiation. We know it's going to be 1 over y times dy by dx. On the right hand side, I have x times natural logarithm 2. Please note that natural logarithm 2 is just a constant, which can be factored out using the second property of differentiation and simply differentiate the function of x. Therefore, it will be ln 2 times the derivative of x, which is equal to just 1. Now, all I have to do is multiply both sides by y. When I multiply both sides by y, you can see from the left hand side, these y's are cancelled, and then we get the final answer to be dy by dx equals y times natural logarithm 2. If the question wasn't given as y equals, you will still have to define a y, but in that case, the y is defined by yourself. Therefore, in such cases, I will replace the y with the given function, which is 2 to the x. Of course, in this case, I do not need to write it that way because the question was originally given to you as y equals 2 to the x. However, if it wasn't given, I will keep the final answer as dy by dx. I know the y is equal to 2 to the x, so it will be 2 to the x times natural logarithm 2. That's how I will answer that problem. Now we will look at another example. Here is your example number 2. Differentiate y equals 6 times 5 raised to the x times 2x plus 5 raised to the 3x squared plus 1. That's an exponential function. I will simply take natural logarithm from both sides. When I do so, I will have natural logarithm y on the left hand side. On the right hand side, I will have natural logarithm 6 times 5 raised to the x times 2x plus 5 raised to the 3x squared plus 1. Now I need to apply the properties of natural logarithm and simplify the right hand side. When I do so, of course, the left hand side stays as it is, ln y. On the right hand side, first I have to identify this as 6 times 5 to the x times this function. It's a product of 3 functions. I have to take natural logarithm. So which property is applicable for that right hand side initially? We can use the first property of logarithm. What's the first property again? The first property is if I have logarithm based a m times n. We said this is equal to logarithm based a m plus logarithm based a n. We have a product of 3 functions. Therefore, we can write down the right hand side as logarithm based e, or in other words, just ln. The first function is 6 plus the next function is ln 5 raised to the x. The third function is ln 2x plus 5 raised to the 3x squared plus 1. All right. Now we need to simplify that right hand side some more. In order to do some further simplifications, we can use the third property of logarithm. The third property says logarithm based a m raised to the r is equal to r times logarithm based a m. In other words, we can simply put this exponent right here. So we can do this x and write it here, and we can do the same for this exponent as well, 3x squared plus 1. We can put it down there. So let me rewrite that question we have. It's natural logarithm y is equal to natural logarithm 6 plus it will be x times natural logarithm 5 plus 3x squared plus 1 times natural logarithm 2x plus 5. Please note that I have not yet differentiated this problem, but before going into the differentiation, I need to mention you something important. In this problem, the exponent was originally given inside the parenthesis. If you look at this problem, right here, this exponent, it has more than one component, 3x squared plus 1. However, it was given inside parenthesis, just like a single factor. In case if your question doesn't have these parentheses, this one and that one, if the parentheses were not given with that exponent, please make sure to first write down those parentheses before doing anything else. Because without the parentheses, look at this step. You might forget that this term completely should be multiplied with the natural logarithm 2x plus 5. So the parentheses are required. Therefore, even if the question is given to you without the parentheses for the exponent, please draw the parentheses before start proceeding. Alright, now we will go ahead and differentiate. When I differentiate both sides of this equation with respect to x, on the left hand side I simply have natural logarithm y, which when I differentiate with respect to x will be 1 over y times dy by dx. On the right hand side, this is natural logarithm 6, which is a constant. Differentiated with respect to x, it will be a 0. And then we have to differentiate x times natural logarithm 5. Of course, natural logarithm 5 is a constant which can be factored out, and then simply differentiate the term x. If you differentiate x, it's equal to 1. Therefore, that term becomes just natural logarithm 5. That plus. Now I need to differentiate this part. It's very important that you see it as a product of two functions. The first function is 3x squared plus 1. The other function is natural logarithm 2x plus 5. We need to use the product rule and differentiate that part. So what's the product rule again? If I have to differentiate f times g, let me write it as prime. This is equal to f g prime plus f prime g. Now I'm going to label this component as the function f and this component as the function g. In that case, you can see that f prime should be just equal to 6x, and how about g prime? G prime should be equal to 1 over 2x plus 5 times a 2. Remember, I'm using the derivative of natural logarithm a given function. We have discussed that already, and it's also a prerequisite to understand this discussion. Now we have f, g, and also f prime and g prime. So we can simply go ahead and use these results and write down the answer for that part. It will be f times g prime. So it will be 3x squared plus 1 times the g prime, which is 2 divided by 2x plus 5, plus f prime times g. F prime is equal to 6x, that times g is natural logarithm 2x plus 5. Now we are mostly done, but we still have to do some more because I need to subject dy by dx. In order to subject dy by dx, all I have to do is consider this right hand side completely inside brackets, and then I need to multiply both sides by the y so that I can get rid of the 1 over y term on the left hand side. When I do that, I will have dy by dx equals y times brackets natural logarithm 5 plus 2 times 3x squared plus 1 over 2x plus 5 plus 6x natural logarithm 2x plus 5, close brackets. So this is your final answer. Are we supposed to replace the value of y from the given function? Well, it's up to you. We can just keep the answer as that because y was defined in the problem itself, because this is how the problem was given originally. Therefore, we can keep this answer as the final answer without replacing the y. Alright, so this is the basic procedure of doing these kinds of problems. I will stop the video at this point. If you have any further questions, please feel free to let me know. Thank you so much.